Hello and welcome guys to my third lesson on integration. Today we're going to be going through how we can apply integration to finding the equations of curves. Now this time we're actually given a coordinate, okay? So the question is, the curve f of x goes through 2, 16 and dy divided by dx is 2x cubed. Find the equation of the curve. So we're given a differentiated function, we have to integrate. So we're integrating this. So, 2x cubed becomes 2x to the power 4 divided by 4. And 2 divided by 4 we all should know is a half. X to the power 4. So that's the equation of our curve. We've integrated the differentiated function, so we're back to the original equation of the curve. So, of course we need to add the constant, but here we're given a coordinate, so we have an x value and a y value. If this is the equation of the curve, we can write this as y equals a half x to the power 4 plus c. But we have a y and x value given in the question, so we now need to substitute them into this curve equation. So, 16 equals a half multiplied by x to the power 4, that's 2 to the power 4, plus our constant. So 16 equals a half multiplied by 2 to the power 4 is 16, so that's going to be 8 plus c. Now we can simply subtract the 8 from the 16, moving it across, and we're going to get c equals. And it's going to be 8. So here's the value of our constant. But if we left it like this, we would drop a mark. We have to put this back into the equation of the curve that we calculated here. So the equation is, so we could write y equals, but in the question it does say the curve is f of x. So we should say f of x equals a half x to the power 4 plus 8, which is our constant. There we go, that's the equation of the curve. So that's the first question done. If you like, you can pause the video and have a go at this question yourself if you like, but I'm going to quickly go through this now. So the question says, the curve f of x goes through 2, 8, and f dash of x equals 6x multiplied by x minus 1. Find f of x. So here we're given f dash of x. All this means is dy divided by dx. It just means it's the first derivative of an original function. So, once again we're integrating this, but now we need to put this in a form that we can integrate. So we're actually integrating, expanding these brackets, 6x multiplied by x, that's 6x squared, minus 1 multiplied by 6x, minus 6x. So this is what we're integrating. So, integrating this we get 6x to the power of 3 divided by 3, minus 6 multiplied by, that's going to become 6x to the power 2, I was jumping ahead there, divided by 2. Okay, we can now simplify this. 6 divided by 3 gives us 2x cubed, minus 6 divided by 2, that's 3x squared. Okay, so there's the equation of the curve f of x. So the next thing to do is to input our values of x and y into this. So, 8 equals 2 multiplied by 2 cubed minus 3 multiplied by 2 squared. So, adding the constant on, we get 8 equals 2 multiplied by 8 gives us 16, minus 12 plus our constant. So we're going to get 8 equals 4 plus c. 8 minus 4 gives us c. So hopefully you can see what's going on here. All we've done is substituting our values of y and x into y equals and the function. So now we need to write the equation of the curve, including this c value. So f of x equals 2x cubed minus 3x squared plus 4. So there's the equation of this curve. So there we go, guys. That's the last lesson on indefinite integrals. Next lesson we'll be looking at something called a definite integral, which is where we input an upper limit and a lower limit into our integration. And that can be used to find the area under curves. So thanks a lot, guys. If you haven't already, please subscribe to my channel. And if you haven't liked the video and found it helpful, please do that. Thanks a lot.